So introduction to foundations, designs using EC7 part 1. Okay, EC7 is EC is a Eurocode 7, and part 1 because the part 1 only discuss on the foundation design, while part 2 discuss on the soil investigations. Okay, so what I'm going to talk about, okay, concentrate on practical applications. Okay, brief review of the traditional design approach, understanding on EC7, okay, EC7 Geotechnical Design, Part 1, Chapter 7, PAS, okay, and Malaysia National Annex 2012, okay. So actually, in Malaysia, okay, we may use the Malaysian National Annex 2012. Okay. EC7 design method and partial factor for shallow and deep foundations. Okay. So later on, I will discuss on the partial factor for shallow and deep foundations. Okay. So by next week, I will give an example, okay, for the calculation for the shallow foundations. And then for the next following weeks, there will be a discussion on the deep foundations, and we include several example, okay, on how to use the uh, EC7 for the deep foundations. Okay. Okay. So this is all the list of Eurocode system, okay, where it consists of 10 uh, codes, okay, starting from the Eurocode 0, okay, so they use the term of EN 1990, 1990, okay, on discussion on the basis of design, okay. So I guess for the undergraduate student, okay, you have learned on the design structure, okay, using the Eurocode. Okay, so then we have here EN 1991, Eurocode 1, discuss on the action on structure, okay. So followed by Eurocode 2, which is EN 1992, design of concrete structure, okay. Then they have their steel structure, okay, design of composite steel and concrete structure, design of timber structure, design of masonry structure, and the last one is design of aluminum alloy structure. Okay, so from 1 to 6 include the 9. Okay, so all of the item is discussed on the structure elements. Okay. So then for the geotechnical design, okay, it is covered in Eurocode 7. Okay. Then we have Eurocode 8, okay, which is discussed on design of structure for earthquake resistance. Okay. So ideally, okay, this is the structural Eurocode programs, okay, where the main uh, discussion on the structural design and action on structure, okay, is covered in this Eurocode 1990 and Eurocode 1991. Okay, and then for all element related to the what we call it to the structure material or structure elements, okay, so it has been covered in EN 1992, okay, until 1996, and then plus with 1919. Okay, so all these elements will be encapsulated by the geotechnical design, okay, where we understand that all the structure elements is located on a soil on the soil. Okay, so that's why geotechnical design will cover all these structural elements. Okay, then there will be additional discussion on the earthquake resistance. Okay, which is it will be affected all these structural elements. Okay, so that's why this diagram to discuss on the Euro application of the Euro codes. Okay, where the main element is located or the truss element is located at the center. Okay, and all discussion on the structure will cover the main element, and it will be encapsulated by this geotechnical design and earthquake resistance. Okay. So the objective of the Euro codes as a mean to prove compliance of building and civil engineering works with the essential requirement of mechanical resistance, instability and safety in case of fire. Okay. So that is the objective, the first objective for the Euro codes. Okay, where the discussion is to provide a stability, okay, mechanical resistance and safety in case of fire. Okay, so then the second one is to as a basis for specifying contracts for construction works and related engineering service. Okay. Number third is a framework for drawing up harmonized technical specs for constructions products. Okay. So the fourth one is to improve the functioning of a single market for products and engineering services by removing obstacles arising from different nationality codified practice for the assessment of structural abilities. And the last one is to improve the competitiveness of the European construction industry and its professional and industry in country outside the European Union. Okay. So as we know, previously, United Kingdom is a part of the EU member. Okay. So in that context, okay. So the UK has uh, start to implement, okay, the Euro codes in their design. Okay. Uh, because Malaysia has used the British standard previously. Okay, so when the UK have changed to the Euro codes, okay, so we follow the standard that's been used by UK. So that's why we use the Euro code in our new design for the structure. Okay. So Eurocode design methods, all the Eurocodes are all based on a common design methods. Okay, the common design method is presented in Eurocode 1990. Okay, a common loading code for all Eurocode is presented in Eurocode 1991, which is under the action. Okay, so the Eurocode share a common terminology and symbols. Okay, so there is not a major changes. Okay, in the Eurocodes. Okay, we still rely on the common theory. Okay, however, there are some modifications. Okay, because previously, okay, we have decided, for example, the factor safety, okay, to be used. Okay, for example, in foundations, okay, commonly we use factor safety of 3. Okay, but here in Eurocode, okay, so our output is to determine what is the factor of safety. Okay, so means that based on our calculation, okay, we may have a result for the factor safety. Okay, as long it is more than 1, okay, so it is satisfied with the Eurocode design. Okay. So if you are interested to look on the common design method, so you can refer to the EN 1990. Okay. And if you want to have more understanding on the loading, okay, so you can get the EN 1991. Okay. So for Eurocode 7, okay, the discussion is more on the geotechnical design, okay, where they include all the partial factor safety, okay, or any coefficients related to the material, to the load, and also to the geometry. Okay, so we may look on the factor that normally been used in the shallow and deep foundations. Okay, when we discuss during the shallow and deep foundation content. Okay, the common design method for the verification of safety and serviceability involve the limit state design method, okay, partial factors, characteristic actions and material parameters or resistance, okay, and reliability base. Okay, so this is the common design method, okay, where under the limit state design, okay, we already know that we have the ultimate limit state and also serviceability limit state. Okay, so we still use the ultimate limit state and stability limit state as well to design or to have the input of the load, okay, or the capacity of the soil, okay, and then we may apply a partial factor, okay, in the design. Then, and in addition, the application of characteristic action, material, diameter, or geometry and resistance will be included, okay, in the calculation. Then reliability base, okay, which is more related to statistical approach, also included in the discussions. Okay. So at the end, it may reduce the uncertainty, okay, in the design, okay. So we can have a better design output, okay. And for example, for designer 1 and designer 2 or designer 3, okay, so at the end there we have the same what we call as factor of safety, so it can harmonize um, the output of the design, okay, between uh, or among other designer. Okay, so that is the objective of the Eurocodes. Okay. So then we look on the comparison between the Eurocode and the British standard. Okay, the construction industry has traditionally used British standard as a benchmark for what is considered good industry practice. Okay. So it has, however, been reported only 29% of civil engineering organizations are prepared for the introduction of the codes, suggests that the industry is not prepared for the arrival of the Euro codes. Okay. So honestly, I'm not sure this 25%, okay, refer on what years, okay, because this is slide prepared by Prof. Ramli, okay. But I guess currently we are getting better, okay, because most of the authority, okay, for example, public work department or local authority, okay, has asked all the designer to prepare or to submit their design by using the Euro codes. Okay, so it is important to recognize that from now they will dictate, okay, the required standard for most public project. Okay, so this is the one that I have stressed. Okay, so now most of the public project, okay, has asked um, all the designer, okay, to submit their design by refer to the Euro codes. Okay, over time the replaced British standard will become out of date and will probably be eclipsed by the Euro codes. Okay, so as a designer, yeah, after we graduate, so we may after you are graduate, so you may involve in designing, okay, either structure or geotechnique. Okay, so you need to prepare, okay, or to have some idea, okay, on the use of these Euro codes. Okay, so I guess for the structural top subject, okay, most of your topic, okay, has already used the Euro codes. Okay, but in geotechnique, for example, geotechnique 2, okay, uh, for the undergraduate, okay, you still using uh, the 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 conventional methods. Okay, okay. So with regard to defect disputes, issue often include whether or not work has been completed to the industry standard. Okay, in this case, it will likely that the Euro code will become the benchmark. Okay, the Eurocode are limit state code like the British standard, although are perhaps a little more explicitly based in reliability theory. Okay, the Eurocode are also less prescriptive than the British standard, with more aspect left open to the designer. Okay, so in Eurocode, they provide a freedom for the designer, okay, in order to put their justifications, okay, in their design, okay. So compared to the British standard, okay, we need to follow exactly what has been written in the standard. Okay. Okay. So this is the list of the advantage, okay, by using the conventional and Eurocode methods. Okay. Okay, for the conventional design, uh, using the global factor safety and simple application, okay, then it is also accustomed to use. Okay, we are familiar to use this conventional design. Okay, because in our um, lecture or in our topic, okay, in the university, okay, uh, previously we learned on the based on the conventional design. Okay, so the advantage of the Eurocode, okay, it use the partial factor safety and harmonic design. Okay, as I told you before. Okay, for example, at the end of the calculation, okay, so all the designer will have the same factor of safety, okay, uh, as we compare to the conventional way, okay, we already stick with one factor of safety, okay, in the design at the early stage, okay. So type of float has different level of uncertainty. Okay, so by using the partial factor safety, so they have a different type of coefficients to be applied on each load. Okay, so uniform level of safety, and also it include a risk assessment. Okay, where they include the reliability approach. Okay. Okay. However, the disadvantage, okay, on the conventional design, okay, so inadequate amount of variability, okay, stress is not good measure of resistance, factor safety is subjective, okay, no risk assessment has been discussed, okay. However, for the Euro codes, definitely is more complex, okay, all habits require availability of statistical data, resistance factor varies, okay. So for me, it's very complicated, okay, to understand on how to use the Eurocode, and sometimes it's also time consuming, okay. However, it can provide a more confident, okay, for the designer by using this Eurocode, because at the end, our aim to provide for a very safety design. Okay, so that's why we need to have a very thorough analysis. Okay, include all the variable that we may include in the design. Okay, and then include all the partial factor safety in the design. So that's why the Eurocode is more complicated and complex. Okay. Okay. So this is some of uh, a background on Eurocode 1990, okay, where it is a general, what we call it, general basis of structural design, okay, in Eurocode 1990. Okay. So Eurocode 1990 describe the principle and requirement for safety, serviceability, and durability of structures. Okay. It is based on the limit state concept used in conjunction with the partial factor methods. Okay. For the design of new structure, Eurocode 1990 is intended to be used for direct application together with Eurocode from 1991 to 1999. Okay. So that's why I already told you that the Eurocode 1919 is the main or the or is the main, okay, to be used, okay, for the basis of structural design. Okay, so Eurocode 1990 also give guidelines for the aspect of structural reliability relating to safety, serviceability, and durability. Okay, for the design cases not covered by Eurocode 1991 to Eurocode 1919. Okay, where other actions are actually not treated other material. Okay, so that's why 1990 is a general guideline, okay, to be referred. Okay, and to serve as a reference document for other standard, okay, they call as CEN, European Committee for Standardization, TC, concerning structural matters. Okay, some of the discussion in Eurocode 1990 also has been used by the CEN as well. Okay. So I didn't have the copy for the Eurocode 1990. So if you are interested, so you need to try to get the copy. Okay. I guess we can get it from the library. Okay. I mean the UTM library. Okay. So Eurocode 1990 is intended for use by the committee drafting standard for structure design and related product testing and execution standard, okay, and client as well for the formulation of their specific requirement and reliability level and durability, okay. So I guess in Eurocode 1990 they also discuss on the durability of the material as well, okay. So designer and contractor relevant authority should have understand well in the Eurocode EN 1990. Okay. So EN 1990 may be used when relevant as a guidance document for the design structure outside the scope of Eurocode 1991 to 1999 for assessing other action and their combinations, modeling material and structure behavior, assessing numerical value of the readability formats. Okay? Actually, Malaysia also have this what we call as a guideline. Okay, they call as a Malaysian standard. Okay, so majority of the content has followed the Eurocode EN 1990 to 1999. Okay, however, they are slightly different. Okay, especially on the Malaysian standard 1997, which is related to geotechnical uh, design, because we may use it in our design calculation. So I noticed there are some difference in terms of the number of the coefficients. Okay. So this standard gives alternative procedure, values, and recommendation for classes with notes indicating when national choice may have to be made. Okay, so this is what I have mentioned before. Okay, so that's why Malaysian has come up with uh, our own Malaysian standard. Okay, to be fit or suitable for our Malaysian conditions. Okay? So therefore, the national standard implementing EN 1990 should have a national annex, okay, containing all national determined parameter to be used for the design of building and civil engineering works to be constructed in the relevant country. Okay, so that's why Malaysia have their own standard. Okay, however, they adopt the content from the Eurocode 1990, okay, and also to 1999. So when we refer to the EN 1990, okay, so there are sections discussed on the national choice, okay, is allowed in Eurocode 1990 through this all section, okay, starting from A 1.1 1, okay, until A 1.4.22. Okay, so I will not discuss in detail, okay, but the gist of the discussion is to mention here that the Eurocode 1919 allow for any country to produce their own standard. Okay? So assumption, the general assumption of Eurocode 1919, the choice of the structure system and the design of the structure is made by appropriately qualified and experienced personnel. Okay. Execution is carried out by personnel having the appropriate skill and experience. Okay. Adequate supervision and quality control is provided during executions of the work in design office, factories, plants, and on site. Okay, so means that a qualified person, okay, or personnel, okay, um, and experience is the main characteristic, okay, for for those who want to design for the structural system. Okay, so at the same time, okay, supervision should be carried out, okay, adequately at the site, okay, and also should have a good quality control, okay, during the execution process. Okay. Okay, the construction material and product are used as specified in Eurocode 1990 or in 1991 to 1999 or in the relevant execution standard or reference material or product specifications. Okay, so the discussion on the material, okay, we can have it is already listed or discussed in this Eurocodes. Okay, the structure will be adequately maintained. Okay, so we need to have the what we call the designer or the contractor should have a proper maintenance schedule. Okay, the structure will be used in according with the design assumption. Okay, so for example, if we want to build what we call as guard house. Okay, so it doesn't require, okay, for us to carry out for a very extensive soil investigation work. Okay, compare if we want to build a double story or high-rise building. Okay, so we should have a very good or very extensive soil investigation work. Okay, in the where we can use all the input in the design. Okay, so it depends on the purpose of the or the function of the building. Okay, so then in the all the Euro codes, okay, they use the terms of principle, okay, which is mandatory requirements. Okay, so principal clauses is the code are identified by a P after the clause number and contain the word shall. Okay, so all other clauses are applicable rules that indicate the manner in which the principal design may be shown to comply with the principle. Okay, so application rules are only informative, okay, which is not mandatory, and for information only, I use words such as should and may. Okay, so when you discuss or look on the example or look on the Eurocode, okay, you may uh, notice there are principle and applications rule or informative, okay, uh, to describe which one is compulsory or mandatory or which is not, only for information. Okay, so that is for the Eurocode 1990. Okay, so now we look on the Eurocode 1997. Okay, okay. On the Eurocode 1997, consists of two parts. Okay, so they have a part one. Okay, Eurocode 1997 1, which is discussed on the geotechnical design. Okay, general rules. Okay, and the part two, which is EN 1987 2, discuss on the ground investigation and testing. Okay. However, in Malaysia, okay, we only have the MS 1987 part 1, and part 2 is not released yet, okay, due to some still there are ongoing discussion, okay, especially on how to conduct for the ground investigation. Okay, either using the rotary drilling or wash drilling. Okay, because if refer to EN 1997 part 2, okay, so it is suggested to use the rotary drilling, okay, because they want to gain a very reliable data compared to the wash drilling. Okay, However, it's not very practical in Malaysia to use the rotary drilling because it's very expensive. Okay, and majority of the SI contractor, okay, is still using the wash drilling methods. Okay, so that's why they still in the discussion. Okay, to release the part two. Okay, once they have uh, gained what we call as the same understanding. Okay, either to use rotary drilling or wash drilling approach. Okay, so it is important to appreciate that Eurocode 1997 Part 1 is not a detailed geotechnical design manual, but is intended to provide a framework for design and for checking that a design will perform satisfactorily. Okay, that is that the structure will not reach a limiting condition in prescribed design situation. Okay, I guess it is the same approach with British standard BS BS because the 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 idea is to make sure that the structure is in a safe conditions. Okay? So the code therefore provides in outline all the design requirement for conducting and checking design. It provides only limited assistance or information on how to perform design calculation, and further detail may be required from other texts such as standard soil mechanics book and industry publications. Okay, so that's why we still rely on the theoretical part. Okay, for example, for the bearing capacity on shallow foundation, okay, we still use the Meyerhoff or Terzaghi approach, okay, in the design, okay. However, a slightly difference in terms of the approach by in by using a different partial factor safety, okay, in the design compared to the British standard approach, okay. So I will include a reference book, okay, written by Smith, okay, for the next class, okay, when we want to discuss on the shallow and also on deep foundations, and then I will upload in your e-learning as well. Okay. So part two covers ground investigation and testing. Okay. Okay, the application of the code in Malaysia require reference to the Malaysian National Annex, which provide the partial factors prescribed for use in the Malaysia. Okay, that's why there are slightly very minor difference. Okay, to be uh, to be uh, 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 to be familiar with Malaysia conditions. Okay. So the Malaysia Annex Part 1 will be available in 2012. Okay, it's already available. Okay, so I will also include the Malaysian standard. Okay, in your what we call in your e-learning. Okay, after the class. Okay, so so you can have some idea. Okay, when we discuss on next following weeks on the shallow foundations. Okay, a series of geotechnical execution standard covering geotechnical processes just such as piling works and grouting also exist. They are preliminary of interest to construction, but also of general interest to designer. Okay. So it describes the general principle applications rule, okay, similar with EN 1990 as well, okay, where they have a principle and application rule for geotechnical design, primarily to ensure safety, serviceability, and durability of supported structure that is of building and civil engineering works founded on soil or rock. Okay, principle are mandatory. Okay, while principle, oh yeah, and then principle clauses in is the code are identified by a P after the clause number and contain the word shall. Okay. So similar with the 1990, where they have the application rule that indicate the manner in which the design may be shown to comply with the principle. Okay, application rules are informative and use words such as should and may. Okay, so the content of Eurocode 1997 Part 1, okay, they have a section of general, basis of geotechnical design, section 3, geotechnical data, section 4, section 5, okay, and then up to section 12, okay, where they discuss on the embankment, okay. However, on the section 8, okay, for the anchorage, okay, part still not apply in Malaysia, okay. I'm not sure why it's not ready yet, okay. However, we all the other section has been addressed in the all part in EN 1987 1 part 1. Okay, so the annex is informative. Okay, so this is annex for the Malaysian standard, okay, which means that the partial factor listed must be used, okay. However, the value of this factor are a matter for national determination, and the value shown is in the annex are those only recommended. Okay. So for the annex, we have the annex A, okay, until annex J. Okay. So annex A used in section 6 to 12 as it gives the relevant partial and correlation factors and their recommended value for ultimate limit state design. Okay. Then Annex A is normative, which means that it is integral part of the standard and the factor in it must be used, although their value are informative and therefore will be modified, okay, in the national annex. So then in the standard also we have the Annex B, okay, where the Annex B gives some background on the information of the three alternative design approach permitted by EN 1990, okay, and given in 1997 as well, okay. So C to H, okay, where C to G provide example of internationally recognized calculation method for the design of foundation or retaining structure, and C to J are informative, which means that in principle they may superseded in national annex. Okay, so then I will give all this Malaysian standard annex to you as well. Okay, in what we call in the e-learning. Okay, so you can get some idea. Okay, but I guess the most important thing is to look on the what we call it on the example, okay, given in the reference book. Okay, that is very easy to understand on these Euro codes. Okay, so for the Malaysian standard or Malaysian standard annex is not very thick. Okay, it only have 12 sorry 22 pages, okay, written pages, okay. So among the member of technical committee, okay, on geotechnical work is Prof. Ramli, okay, from our department. Okay, and they also include one academician from University Technology Mara, which is Associate Professor Dr. Jamaluddin Matno. Okay, so all these members of technical committee has put their idea in preparing this Malaysian annex. Okay, so now we move to the design philosophy in Eurocode 1997. Okay, an understanding of limit state design can be obtained by contrasting it with working state design. Okay, so working state design analyze the expected working state, then apply margin of safety. So we have the limit state design, analyze the unexpected states at which the structure has reached an unacceptable limits. Okay, make sure the limit states are unrealistic or at least unlikely. Okay, so in the design philosophy, so they rely on the limit state approach. Okay. Eurocode 1987 Part 1 is a limit state design code, which means that a design that comply with it will prevent the occurrence of a limit state. Okay, so a limit state could be example be an unsafe situation, okay, damage to structure, economic loss. Okay, okay, while there are in theory many limit state that can be envisaged, okay, it has been found convenient to identify two fundamentally different type of limit state, each of them having its own design requirement. Okay, so we have the ultimate limit state, ULS, and serviceability limit state, SLS. Okay, so I guess most of you has some have an idea what is ULS and SLS. Okay, so ULS is more related to the safety or stability of the structure. Okay, while SLS is more related to deformations. At the end, it can provide a comfortness to the user. Okay. So ULS are defined as a state associated with collapse or with other similar form or structure failure. Okay, failure of the foundation due to insufficient bearing resistance. Okay. In the technical design, ULS includes failure by excessive deformation, loss of stability of the structure or any part of it. Okay, so we have the excessive deformations. Okay, means that when they have excessive deformation, so at the end they will near to a collapse failure conditions. Okay. Here's a state in which part of a structure becomes unsafe because of foundation settlement or underground movement should be regarded as a ULS even if the ground itself has not reached the limit of its strength. Okay. So we still can consider when it has a very excessive deformations, so it can consider as under ULS as well. Okay. Ultimate limit state of a full collapse or failure of the technical structure are fortunately quite rare. Okay, it's very rare to happen if we apply a very good adequate factor safety. Okay. However, an ultimate state may develop in the supported structure because of large displacement of a foundation, which has itself not failed. Okay, this means, for example, that a foundation may be stable after initially settling. Okay, that's exceeded a ULS or fail, but part of the supported structure may have failed. For example, a beam has lost its bearing and collapsed owing to substantial deformation in the structure. Okay, so this is um, an example, okay, where we can consider the foundation is safe, okay, okay, after settling, okay, but part of structure may have failed, okay. So at the end, so we can say that this phenomenon also can consider under the collapse conditions. Hmm. The principal emphasis of Eurocode is in the definition application of partially factor safety. Okay. Factors are applied to characteristic action, nominal dimension, and characteristic material properties. Okay. So in Eurocode 7, okay, the approach to the design, okay, they use several factor, okay, which is called as a characteristic action, nominal dimension, and characteristic material properties. Okay, so it means that they apply a partial factor safety on the action, on the dimension, and also on the material properties. Previously, we only apply the factor of safety or partial factor safety on the action only, okay, not on the dimension and also on the material properties. Okay. These are considered through calculation with a view to ensuring that the design effects are less than or equal to the design resistance. Where relevant, the code requires a total of 5 different ultimate states to be considered. Okay. So in this Eurocodes, they use 5 different ultimate state in the design. Okay. So they have EQU, okay, which is related to the equilibrium of the structure. Okay. So they have a STR, which is called as a structure. Okay. Internal failure or excessive deformation of the structure or structural element, including footing, pile, basement wall, in which the strength of the structural material is significant in providing resistance. Okay. Then they have their geo failure of excessive deformation of the ground, in which the strength of the soil or rock is significant in providing resistance. Okay, for example, overall stability, bearing resistance of straight foundation or pile foundation. They have the UPL, loss of equilibrium of the structure or the ground due to uplift by water pressure or buoyancy of or other vertical action. And the last one is the HYD, okay? Hydraulic lift. Sorry, I have a call. Let me answer the call first. Okay. So then we have the HYD, hydraulic shift, internal erosion and piping in the ground caused by hydraulic gradient. Okay. So it depends on the situation. Okay. What will be uh, the the uh, the condition of the for example of the site. Okay. So normally in the design for shallow foundation, okay, or deep foundation, we may use the STR and also the GEO only. Okay. So in some situation, okay, we may use the EQU, sorry, EQU. Okay. For example, for a retaining structure, okay, where they have a loss of equilibrium. Okay. So that is the way how they include all these five limit state design. Okay. So it's not very common for the geotechnical design, okay, to use the UPL and HYD. Okay. Okay. So okay, this is an example of the STR. Okay, internal failure of structure. Okay. So for example, if we are using pile, so we need to refer to the STR. Okay, what is uh, the partial factor safety should be used. Okay, then we have the geo. Okay, so most of geotechnical design is related to geo. Okay, so then we have the EQU, okay, loss of static equilibrium. Okay, for example, this is happen especially for a retaining structure. Okay, then we have UPL, uplift by water pressure, HYD, hydraulic heave erosions. Okay. So an exception to application of partial factor is made in relation to water pressure. Okay. It is recognized that the application of partial factor to water pressure can, in some circumstances, lead to unrealistic high water pressure. So means that for the water pressure, we may not apply for any partial factor. Okay. Okay. So in this case, it is suggested that suitable margin of safety be applied for characteristic water pressure. Okay. Three basic design approach are permitted in the assessment of ultimate limit state and are applied according to local practice. Okay, for the what we call for the water pressure. Okay, for most simple geotechnical design situation, the geo limit state will be critical to the sizing of the foundation and structural member. Okay, as I told you that this is the common limit state, okay, to be used. The section of the code covering specific design issues such as pile foundation and spread footing give advice on the limit state that need to be considered. Okay, where groundwater is present in excavation or cutting, the UPL and HYD limit state need to be considered. Okay, because we are not discuss on the excavation, okay, or cutting in shallow and also in deep foundation. So that's why we not use the UPL and HYD. Okay. The STR limit state is less well defined, but is nevertheless very important in some design situation. The STR case might become critical when imposed loading causes deformation of some part of the structure or deformation of the ground imposed deformation on the structural member. For example, if we are using any uh, structure, for example, pile. So we need to include the str, okay, in the limit state approach. So for most of the design problem likely to be encountered, the str and geo ultimate limit state are the one that we apply as they cover the routine design for shallow and far foundation and other common geotechnical structures. So the combination between str and geo is a common for the pile foundation or deep foundation or shallow foundation. The EQU ELS is intended to cater for rare occasion when, for example, a rigid retaining wall bearing on the rigid roll foundation could rotate about one edge of its base. Okay. The UPL and HYD ULS, while some common than UQU, are generally beyond the routine. Okay. So means that it is not common to use the UPL and HYD. Okay. Okay, so this is the unrealistic possibility, okay, which is it reach the failure condition, okay. So means that we try to make sure that when we apply the Eurocode in the design, as Eurocode, we use the Eurocode in the design, so this unrealistic condition is will not be happen. Okay. Okay. So we should have a 5 minutes breaks, okay, and then we will continue later. Okay, so we have 20 slide more. Okay. So we should have a 5 minutes. Then we continue at 11:11. Okay.